In this video tutorial, we answer the question, what are complex numbers? So complex numbers can be used to write down solutions for any polynomial equations. And more importantly, complex numbers are a combination of real and imaginary numbers. Let us look at a simple example. So let us say that we have x squared plus 2x plus 5 equal to 0, and we want to solve for x. Now we notice that we cannot factorize this trinomial. So let us try and solve for x by using the quadratic formula. So that is x is equals to minus b plus minus the square root of b squared minus 4ac over 2a. So if I substitute values in, I have b as -2 plus minus 2 squared, which is 4, minus 4 times 1 times positive 5, and we take the square root of those terms over 2 times 1. And when we simplify further, we have x is equals to -2 plus minus the square root of -16 over 2. Now, we know that the square root of -16 can be written as the square root of 16 times -1, which is equals to 4i, where the square root of 16 is equals to 4, and the square root of -1 is equal to I, the imaginary number. Therefore, x is equals to -2 plus or minus 4i divided by 2. And if I simplify further, I see that x is equals to -1 plus minus 2i. Therefore, I have two possible values of x. X can be equals to -1 plus 2i, or x can be equal to -1 minus 2i. Now notice these solutions. In our first solution, we have a real number and an imaginary number. So this solution is known as a complex number. Also, our second solution consists out of a real number and an imaginary number. So this is also a complex number. So if we say, for example, that x is equals to 3 plus 5i, we know now that this is a complex number consisting of two parts. One part is a real number, and the other part is an imaginary number. So our normal notation would be to say that complex numbers are noted as z, where z is a real number plus a coefficient times an imaginary number. And our notation is the real part of z is equal to a, that is the real number, and the imaginary part of z is equal to b, the coefficient of the imaginary number. Let's say, for example, we just have -5i. So -5i is also known as a complex number, but it does not have a real part. So there's not a real number in front of -5i or combined with -5i. But alone, this is also a complex number. And if we look, for example, at the number 3, the number 3 is a real number, but it's also a complex number with no imaginary part. So a real number can also be known as a complex number. So there we have it. We can have complex numbers that consist out of a real part and an imaginary part. If we want to consider the real part only, we only look at the real number. And if we want to consider the imaginary part only, then we only look at the coefficient in front of I. And those are complex numbers.